folks, I'm Keith Bowen and this is Hard Rock University. Now I'm in a little bit of a hiatus here. Hopefully I'll be heading to New York by the end of the month and doing some construction and some prospecting and maybe even recovering precious metals from electronic scrap. So I have some trip reports and this, that, and the other. Well, I realized a short time ago that while I remember all my videos, a lot of you people haven't seen them all. I've got over 100 now. So I'm going to go back and kind of redo some things that I've done previously, and we'll see how that works out. One thing I'm going to do is try and do a little systematic overview of milling procedures, extractive metallurgy. How do you get valuable minerals out of rocks on a basic theoretical basis? And the things you're trying to do is get all the good stuff out without losing anything. I mean, if you had some kind of milling process that would get you 100% of the valuable mineral in 100% pure state while leaving nothing left in the rock, that would be fantabulous. That's also called magic. In the real world, you're trying to balance a whole bunch of different factors: the cost, the efficiency, the throughput, the recovery percentages, all these sort of things. So there's a lot of principles that come to bear on this. It's all balancing. It's all trade-offs. So you have to understand the principles to come up with the most efficient system and the most money in your pocket for the least amount spent. Now, one of the basic operating principles in many industrial mills is something that most people don't use on a small scale. On a micro scale, it's hardly ever seen. It's called the rougher, cleaner scavenger system. It's the standard method on flotation cells. And the purpose is to get you the cleanest concentrate with the least amount of loss. Now those are two things that are directly antithetical. By trying to get the cleanest concentrate, you're throwing as much stuff away as you can, which means you're going to throw away some of the good stuff too. On the other hand, if you're trying to get maximum recovery, you're going to tend to gather more of the undesirable minerals, what they call the gangue, G-A-N-G-U-E. Basically it means crap in fancy talk. Okay? So you're trying to balance this, and one method that works real well is the rougher, cleaner scavenger circuit. This is a little bit technical, it's not too bad, but I'm going to have to go to the whiteboard because it is a little bit complicated. So let's go to the whiteboard and see how this works. Okay, so this is the initial basic concept for recovering gold from the Mojave 1 ore with the equipment I have on hand. I have a Keen hydromatic jig. Theoretically takes about a ton an hour. Seems like it does about that. I have a table, experimental table I'm building myself that seems to do about 200 pounds an hour or something around there. So let's assume that we had like 1 ton per hour of ore coming in as a slurry to the jig. The jig is getting 70% recovery. And then the concentrates from the jig go to the table, which is getting about 80% recovery. And then you have tailings coming off of the jig. Now, assuming I start with 10 tons of ore at 1 ounce per ton and 1% heavies. Now the heavies in this case probably contain a lot of gold. Sometimes they can be a valuable material in themselves, like say a chalcopyrite or something like that. You can sell it to a refiner and make money, including the entrained gold. But for whatever reason, I'll put the heavies in here also. They may be valuable, they may be not, but it just shows you exactly what happens here. Now, let me go ahead and stop for a second and put in some actual numbers here. So here's what we have once I've actually put the numbers in. You have a total of 10 ounces of gold and 200 pounds of heavies coming into this. You're recovering 70% at the jig, so you lose 3 ounces and 60 pounds there. You send 7 ounces and 140 pounds of heavies to the table. By the time it does its thing, you've recovered into a final product that's running around 50% heavies, 5.6 ounces of gold, 112 pounds of heavies. You've lost another 1.4 ounces and 28 pounds. Your total losses are 4.4 ounces, 88 pounds, and you're only looking at a total recovery of 56% recovery. Now that's not real good. Let's see what we can do to dramatically improve that without adding a whole lot of complexity or cost to this system. Now if you look at this circuit here, I've added one major component, another jig. Now you would think, well, this is going to scavenge some of the stuff off, and that's a good thing. But where does it go, and how do you keep from throwing it away? That's where the rougher, cleaner scavenger circuit comes in. This is called the rougher. The material comes in, it goes through the rougher, the concentrates go to the cleaner. In this case, it'll be a table. The tailings go to the scavenger. Its job is to get whatever good stuff it can still remaining in there out of it, but the grade of those concentrates is going to be pretty poor. Not nearly as good as these. So where the heck do you put those? Well, you send them right back to the rougher. Okay? Now, this purple marker is going to be the next iteration of this. The table, it creates these concentrates. What does it do with the tailings? They've still got a lot of gold in it. In this case, about 1.4 ounces in 200 pounds, roughly. Yeah? Well, actually in 1 ton. So that's over an ounce to the ton. That's pretty expensive to be throwing away. Oh, wait a minute. What were we throwing in here? About 1 ounce to the ton. So send it right back here. Okay? Now, it gets more complicated than this, but to make it easy to see, I'm going to run one more iteration with these red flows indicating the recirculation of the concentrates from the jig and the tailings from the table here. And we'll see what kind of numbers we get with this. Now mind you, it'll get better than this in the long run. Now I've got the flows and the percentage recoveries in red here for the second iteration. Now obviously the easy stuff is going to get caught almost 100% the first time. The stuff that you're going to miss is going to be the harder material. So I've taken my recoveries down for this secondary recovery cycle. So as we come in from the primary roughing circuit with the primary ore, we get a 60% recovery. The concentrates from the scavenger and the tailings from the cleaner go back into the jig here, and they're not going to get as good a recovery. So figure the jig's only going to get 60% of those. By the way, these are pretty conservative numbers in my opinion. I think they're actually higher in practice. But it's going to get 60% recovery, and then of the stuff that it recovers and sends back, I'm only saying I'm going to get 30% recovery of that in the jig to send back up again. So, in the second iteration, we start with losses that originally were 4.4 ounces and 88 pounds. We cycle it back here, recover it there, we take this, cycle it back there, right there. We recover another 1.85 ounces and 37 pounds of concentrates, and we only lose 2.5 ounces instead of the original 4.4. So let's see what the totals are. So out of a total of 10 ounces input into the system, our recovery's now gone up to 7.45 ounces, or 74.5%. Funny how it rounds off numbers when I pull numbers out of the air, right? Wonder why I came up with that 10 tons initially. But anyhow, we have now gone from 56% recovery to 75% recovery by adding this and recirculating some of the material. So we gained almost 50% of our original recovery, from 5.5 to 7.5 ounces. Now that's pretty good considering we only added one jig, and we're going to have a pump in here now. Before, this could gravity run to that, but now these have to be pumped back uphill again. So you're going to have one slurry pump of some sort. You can have a little jet pump, slurry pump, whatever. But anyhow, you can do it manually if you want. But anyhow, so that's what you wind up doing here. You've improved your recovery. You've got almost 50% more gold with only one more jig, one more pump, and a little bit more effort. Okay, so let's see if we can do even more just by changing the flow sheet. The exact same equipment, but just changing the direction of flows a little bit. This time, instead of taking the concentrates from the Scavenger jig and sending it back to the cleaner, the rougher, I'm going to send it to the cleaner. I think I can reduce the flow rate of concentrates from these two jigs enough to not overrun my table without losing too much. I think that the volume of concentrates per ton of input can be dropped significantly without much losses, because we only have 1% solids. 1% heavies. So I don't think we're going to oversaturate these. We'll run a little bit higher grade to the table, and we'll run the cons from both jigs. Now I've recalculated everything. Notice here I've got, in blue would be the stuff from this iteration, in red from this iteration, and then it comes back up here. What I've got when I'm done, and somewhere I've gained a half an ounce. So that's really good. I love gaining, a half an ounce by simply changing things on a blackboard. But apparently my calculations have gotten a little bit complicated. There's so many iterations and feedbacks now. It's not a simple calculation. It's a complex series of iterations. But anyhow, it looks like I'm going to get somewhere around 8.5 ounces now. So instead of 76% recovery, I'm now getting 85% recovery simply by changing this flow sheet here. That shows you how important it is to just pay attention to the flow sheet, do the calculations, and see what happens. Because this makes a big difference compared to this. That's almost 10% recovery right there. So this is how you play these games. This is how you test them. Then you go out and you actually do it, measure everything, assay your various products, use your panning technique to dial it in, get it tuned in, then assay to confirm. And now we're looking well over 80% overall recovery and getting a nice clean concentrate. With my table I will get, depending upon the type of gold, I can get most of the gold as a smeltable gold concentrate, something running like 10-20% gold at least, and the rest of it is a high-grade heavy mineral concentrate. With Mojave 1, it's hard to tell. I bet you a lot of it's still in the arsenopyrite and will have to be either leached or sent off for custom refining. But that will get us at least, now we're looking in the order of 20 pounds a day of high-grade, now 200 pounds a day of high-grade concentrate that needs to be leached. That's not much. That's 4 buckets full. A single barrel would be able to leach that. Just a big plastic barrel. You could easily do that in a day with a fairly good kinetic leach, like a thiourea or something to that effect. Cyanide is still kind of the slowest thing out there. But that's basically how the circulation of your circuit can make a huge difference. That's how a rougher, cleaner Scavenger concept works. And just take your cons and send them upstream, take your tails, send them downstream, one stage, and it'll do a good job. So that's how the rougher cleaner scavenger concept works. I hope it helps you. Happy prospecting and keep it safe out there.